It's important to properly dispose of unwanted medication or sharps. MedProject offers free and convenient disposal options near you. To learn more, call 844-MED-PROJECT or visit medproject.org.
Nice buns, soft, fluffy, and ultra-low net carbs. Discover Hero Bread, the delicious, ultra-low net carb bread with incredible taste and texture. Hero Bread has 0 grams of sugar and is under 100 calories per serving. Plus, high in fiber with 5 to 10 grams of protein per serving. Order from hero.co now and get 10% off your first purchase with promo code AH10. That's 10% off with code AH10. HERO.co.
This is SpaceTime Series 26, Episode 64, for broadcast on the 29th of May 2023. Coming up on SpaceTime, Blue Origin to build a lunar lander for NASA, the search for black holes close to Earth, and more evidence supporting the existence of a vast northern Martian ocean. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA has selected Blue Origin to develop its Blue Moon lunar lander concept to carry crews and supplies between lunar orbit and the surface of the Moon. The new spacecraft will need to be fully operational in time for the Artemis 5 mission, which is currently slated to launch in 2029. The $3.4 billion Blue Origin lunar lander contract follows the awarding 2 years ago of a separate lunar lander contract with SpaceX. SpaceX offered the HLS, a modified version of its reusable Starship interplanetary colonial transport spacecraft. It'll shuttle crews and supplies between lunar orbit and the Moon's surface for the Artemis 3 and 4 missions in 2026 and 2028, respectively. That contract was valued at $2.9 billion. However, both companies would be putting in at least as much again of their own money in order to get the spacecraft developed in time. NASA's head, Bill Nelson, says having 2 separate companies developing different lunar landers will give NASA reliability and backups. Having 2 very distinct lunar lander designs with different approaches as to how they meet NASA's mission needs provides more robustness and should ensure a regular cadence of lunar landings. The Artemis program marks NASA's return to the Moon after Apollo more than 50 years ago. Blue Origin's Blue Moon lander is being developed in association with Boeing and Lockheed Martin, as well as several other partner companies including Draper, Astrobotic, and Honeybee Robotics. Lockheed Martin's involvement will also include developing a space tanker, which will then be used to refuel the Blue Moon lander in lunar orbit. Blue Origin, which is owned by Amazon's Jeff Bezos, plans to use its yet-to-be-flown New Glenn heavy lift rocket in order to launch both its lander and its refueling tanker. The current short-term Artemis rundown looks like this. The unmanned Artemis 1 mission, providing a maiden test flight for the SLS rocket and sending the Orion spacecraft around the Moon and back to Earth again, has been a complete success. Next year, Artemis 2 will repeat that exercise, but this time carrying a crew. Artemis 3, which at this stage is slated for 2026, will see the Orion SLS spacecraft dock directly with the Starship HLS lander. 2 crew members will then transfer to the lunar lander and descend down to the Moon's surface, and they'll stay for about a week near the Moon's south pole, while the remaining pair stay aboard the Orion. The Artemis 4 mission will launch in 2028, with Artemis 5 in 2029. But instead of docking directly with the lunar landers, these will use the yet-to-be-built Lunar Gateway space station, a sort of lunar orbital staging post. Crew can then transfer from their Orion capsules into the docked HLS and Blue Moon landers to shuttle down to the lunar surface and back again. Of course, the Artemis program isn't just designed to return humans to the lunar surface. Its real aim is to get people to Mars. This report from NASA TV.
Between 1968 and 1972, America launched 9 human missions to the Moon, 6 of which successfully touched down, allowing 12 men to walk on the lunar surface. NASA's next chapter of lunar exploration, called Artemis, has the task of not just going to the moon to create a long-term human presence on and around it, but also to prepare for ever more complex human missions to Mars. So, what will an Artemis mission look like? Everything is designed and tested with our most important element in mind, the astronauts. Their deep space, human-rated spacecraft called Orion, built in 3 parts. The crew module, where up to 4 astronauts will live and work throughout the flight. The service module, with life support systems for the crew and its own engine and fuel reserves. And a launch abort system, with engines capable of pulling the crew module to safety during launch should anything go wrong. To accomplish the task of launching our crew and heavy payloads, NASA is building the Space Launch System, comprising of a cargo hold, an exploration upper stage, a massive core stage, and 2 extended solid rocket boosters. Altogether, this is the world's most powerful rocket, and it exceeds the legendary Saturn V of the Apollo era in numerous ways. Sitting on the launch pad, the entire rocket, fully fueled, weighs just over 6 million pounds, 5.2 million of which is just the fuel. Once ignited, there is no stopping what comes next. All 4 RS-25 engines and the 2 solid rocket boosters come to life, thundering our crew upwards. 2 minutes after ignition, the solid rocket boosters are spent and released. 8 minutes after launch, the core stage is depleted and separated. The upper stage fires briefly, placing Orion into a parking orbit around the Earth. Here, the crew reconfigure the spacecraft and check systems to confirm everything is ready for deep space travel. With a go from mission control, the crew reignite the exploration upper stage engines to leave Earth entirely. The exact timing of this maneuver is critical to reach a speed that can escape Earth's gravitational pull, but also put Orion on a course that will intersect the moon days later. Once this burn is complete, the upper stage of the SLS is jettisoned and the crew aboard Orion coast for several days toward all that awaits them at the moon. Approaching the moon, we see the fundamental differences between Artemis and Apollo. Instead of requiring Orion to serve as an expendable lunar command module or to carry a constrained lunar lander, the Artemis missions will take advantage of a different approach: pre-staging. Everything needed for lunar missions will be positioned in advance by commercial and international partners. This includes rovers, science experiments, and human-rated systems on the surface. But it also includes a dedicated lunar station in orbit around the moon called Gateway. Here at this station, we can pre-stage a robust lunar lander and establish a strong communications relay. Designed with open standards, the Gateway can be expanded as new missions and partnerships develop, allowing multiple human missions on the moon at the same time and enabling ongoing science to be conducted even between human missions. The Gateway is also capable of adjusting its orbit to allow access to every part of the moon, something the Apollo missions could not do. But the real key in this approach is placing Gateway in a unique halo orbit to perfect the maneuvers needed for Mars missions. And with the growing list of commercial and international opportunities, Gateway is the ideal hub between Earth and all that lies beyond. Returning to our crew as they approach Gateway, the Orion must match the elliptical orbit of the station in order to successfully dock. Once on board, pre-selected crew members transfer to the lunar lander, while those assigned to Gateway remain on station. The lunar lander system itself is built for 3 unique steps: descending from the halo orbit of Gateway down to a low lunar orbit, descending from low lunar orbit to the surface, and once the lunar mission is complete, launching from the surface of the moon and ascending all the way back to the orbiting Gateway. Once back aboard the Orion spacecraft and undocked from Gateway, the crew fire their engine once to break out of the halo orbit and once again to sling the spacecraft around the moon, placing it on a multi-day trajectory back towards Earth. As they near the end of this journey, the service module is released, and the crew module is oriented heat shield first. Entering Earth's atmosphere at 25,000 miles per hour, the friction of air slows Orion considerably, while also subjecting it to temperatures of 5,000 degrees. With the Orion now at just 300 miles per hour, a series of parachutes uniquely tested and produced for this moment deploy, decelerating the craft to just 20 miles per hour for splashdown. With each successful mission, Artemis ushers in the next wave of men and women to explore our moon and prove that together we are ready to go beyond.
This is SpaceTime. Still to come, a search for black holes close to Earth, and more evidence supporting the existence of a vast northern Martian ocean on the red planet. All that and more still to come on SpaceTime. Astronomers have come up with some of their best evidence yet for the presence of a rare class of black hole, which may be lurking in the heart of one of the closest globular clusters to Earth, Messier 4, located just 6,000 light-years away. One of the big questions puzzling astronomers is why black holes only seem to come in two sizes. It seems there are either stellar mass black holes, which are formed either from the collapse of giant stars or from the merge of two neutron stars, or alternatively, there are supermassive black holes, which are millions to billions of times larger than their stellar counterparts and are found at the centers of most, if not all, galaxies. Astronomers don't seem to find many intermediate-sized black holes, those tens of thousands to hundreds of thousands of solar masses in size. It's been estimated that our Milky Way galaxy is littered with maybe 100 million stellar mass black holes, and the universe appears flooded with supermassive black holes. The long sought-after missing link are the so-called intermediate mass black holes. And for decades, astronomers have been wondering where are they and why are they so rare. Over the years, astronomers have identified a few possible intermediate mass black hole candidates. Two of the best are 3XMM J215022.4 -055108, which Hubble helped discover back in 2020, and HLX-1, which was identified in 2009. Both of these reside in dense globular star clusters in the outskirts of other galaxies. Globular clusters are tightly bound ancient stellar spheres containing thousands to millions of stars, all bound together by gravity. They're commonly found in the halos of galaxies. The Milky Way, for example, has at least 150 globular clusters, and our nearest big neighbouring galaxy, Andromeda, has an estimated 500. Globular clusters are both much older and far more dense than their open cluster counterparts, which are found in the disks of galaxies. Many globular clusters are comprised of stars which are all thought to have originally formed at the same time from the collapse of the same molecular gas and dust cloud. However, others appear to be the surviving cause of ancient galaxies, which have been cannibalized by other galaxies through galactic mergers. So far, the possible intermediate mass black hole candidates discovered appear to be reasonably small, with around a few tens of thousands of solar masses, and they're all thought to have once been at the centers of dwarf galaxies. NASA's Chandra X-ray Observatory has also helped make many possible intermediate mass black hole discoveries, including a large sample in 2018. Looking much closer to home, there have been a number of suspected intermediate mass black holes detected in dense globular clusters orbiting the halo of the Milky Way. For example, in 2008, Hubble astronomers announced the suspected presence of an intermediate mass black hole in the globular cluster Omega Centauri. For a number of reasons, including the need for more data, these and other intermediate mass black hole findings still remain inconclusive, and alternative explanations can't be ruled out. Now, scientists have used the unique capabilities of the Hubble Space Telescope to zero in on the core of the globular star cluster Messier 4, using far higher precision than available for previous searches. The study's lead author, Eduardo Vitrell from the Space Telescope Science Institute in Baltimore, Maryland, says his team has detected what could be a possible intermediate mass black hole of roughly 800 solar masses. A report in the Journal of the Monthly Notices the Royal Astronomical Society says the suspected object can't be seen directly, but its mass can be calculated by studying the motions of stars caught in its gravitational field. But measuring their motion takes time and a lot of precision, which is where Hubble comes in. Vitrell and colleagues examined 2 years' worth of M4 observations from Hubble, studying individual stars near the suspected black hole. Now, the Hubble data tends to rule out alternative theories for this object, such as a compact central cluster of unresolved stellar remnants like neutron stars or smaller stellar mass black holes swirling around each other. Vittrell says he's confident that he's now narrowed down on a very tiny region with a lot of concentrated mass. It's about 3 times smaller than the densest dark mass found before in other globular clusters. And he says the region's more compact than what can be reproduced using numerical simulations, even when one takes into account other highly compacted objects like stellar mass black holes, neutron stars, or white dwarfs. Vittrell says the observations showed that the closer to the central mass, the more randomly the stars are moving, and the greater the central mass, the faster these stellar velocities. He says there's simply no other physics to explain such a compact concentration of mass. A grouping of such close-knit objects would be dynamically unstable, so if the object isn't a single intermediate mass black hole, it would require an estimated 40 smaller stellar mass black holes crammed into an area of space 1/10 of a light year across in order to produce the same sort of stellar motions. And the consequences of that are that they would simply either merge or be ejected out of the system by the immense gravitational perturbations. This report from NASA TV.
It's estimated that our galaxy is littered with 100 million small black holes created from exploded stars, while the universe at large is flooded with supermassive black holes, weighing millions or billions of times our sun's mass and found in the centers of galaxies. A long-sought missing link between the two is an intermediate mass black hole, weighing in at hundreds to thousands of solar masses. Astronomers using NASA's Hubble Space Telescope have possibly detected one of these elusive intermediate mass black holes in the core of the globular star cluster Messier 4, located 6,000 light-years away from Earth. They calculated the suspected black hole's mass by studying the motion of stars caught in its gravitational field using 12.5 years' worth of Messier 4 observations from Hubble. The researchers estimate that the black hole could be as much as 800 times the mass of our Sun. Thanks to Hubble's high-precision observations over a long period of time, scientists can search the skies to help us uncover the mysteries of this missing link and better understand our place in the universe.
This is SpaceTime. Still to come, more evidence supporting a vast northern Martian ocean, and later in the science report, a new study confirms that deep ocean circulation around Antarctica has slowed down. And that's important because it's one of the predictions made in climate change models. All that and more still to come on SpaceTime. Scientists examining data from China's Zhurong Mars rover claim to have now confirmed that a giant Martian ocean once occupied vast areas of the red planet's northern hemisphere lowlands. Orbital observations of Mars show clear evidence of features that look like beaches and seashores bordering what appears to have once been a vast liquid water ocean, an ocean which would have covered much of the Martian northern hemisphere billions of years ago, back in a time when the red planet was a far warmer, wetter world with a much thicker atmosphere than what we see today. And ground observations by NASA rovers have confirmed that liquid water did once flow in the many streams and rivers which appear to have crisscrossed the now freeze-dried desert planet. A popular hypothesis of a paleo-ocean area in the Martian northern lowlands suggests that it would have formed a special marine sedimentary geological unit which scientists call the Visitus Formation. But up until now, there's been no in situ data to support this idea. And that's where Beijing's rover comes in. Now, a team of scientists claim their in situ observations using data from Zhurong provide the first direct evidence of marine sedimentary rocks in the Martian lowlands. The data was obtained by multispectral cameras carried on the Zhurong rover. In 2021, the Zhurong rover, carried by China's Tianwen-1 spacecraft, successfully landed on the southern edge of the Utopia Planitia in the eastern part of the Great Northern Plain. Part of the rover's mission was to search for any possible evidence for or against the existence of an ancient ocean on Mars, which possibly could have hosted early life. After all, here on Earth, wherever you find evidence of liquid water, there's evidence of life. Since landing, the Zhurong rover's been heading south towards potential coastline area, observing the exposed Vicitus formation along the way. Before shutting down, Zhurong travelled about 1,921 metres and used different imaging and analysis systems to conduct in situ observations of rock outcrops and surface features. The navigation and terrain cameras obtained 106 sets of panoramic images, which recorded in detail the surface morphology and structural characteristics of many of the rocks along the way. The study's authors examined the photos sent back by the rover's onboard cameras, finding that the exposed rocks developed bedding structures, which are significantly different from the common volcanic rocks seen in other areas of the Martian surface. And they're also very different from the bedding structures formed by aeolian or wind-driven sand deposition. In fact, these structures indicated bidirectional flow characteristics, and that's consistent with what we see here on Earth in low-energy tidal currents. Since the observed rocks were all located in the Zhurong inspection area, the research team have named the geological feature it represents the Zhurong member. During the study, the authors found that the rocks in this section typically retain local lens-shaped cross-bedding fabrics, mainly composed of a variety of small-scale cross-bedding, accompanied by a small amount of lens-shaped flexure bedding and sedimentary structures which look like small channels. Among these, the layers that make up the cross-bedding overlap, and they tend to tilt in two opposite directions, and that's indicating a bidirectional paleocurrent environment. In addition, since the thicknesses and grain size of the strata have large differences in different directions, it indicates that there are differences in the intensity of paleocurrents in the two directions. This bidirectional water flow pattern is usually formed by fluid action with periodic flow direction changes, and that's not common in aeolian or fluvial environments, but it is common in littoral shallow sea environments on Earth. Of course, compared with Earth's big single moon, Mars has only two really tiny little moons, Phobos and Deimos, and that means any surface tidal action would have extremely low energy, and so only really small-scale bedding structures could be formed in this sort of tidal environment. Still, the bed forms and sedimentary structures identified in the study do show clear evidence supporting an aqueous flow rather than some sort of wind deposition. Overall, the team's observational results of the Zhurong member rocks in this study are providing the first direct evidence which supports the existence of an ancient ocean in the northern Martian plains. And that's significant. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. Scientists have confirmed that the deep ocean circulation around Antarctica has slowed down by approximately 30% since the 1990s. The findings, reported in the journal Nature, confirm the warnings of climate change models which predicted that deep ocean circulation would be about to collapse. Melting glaciers release fresh water into the ocean, and this water is less dense than salty water, and so it reduces the amount of water sinking near Antarctica, slowing the ocean currents. The slowing of the deep water circulation could have serious impacts for the climate, for sea level rise, and for ocean ecosystems. A recent study projected the slowdown of the Antarctic overturning by 40% by 2050, and this new research confirms that this change is already occurring. Australia's National Science Agency, the CSIRO, is warning that micro and nanoplastics are now pervasive in our food supply system and may be affecting food safety and security on a global scale. This study is the first to analyse the academic literature on microplastics from a food safety and food security risk viewpoint, building on past studies which primarily track plastics in fish. It shows that plastics and their additives are present in a range of concentrations, not only in fish but also in many other products, including meat, chicken, rice, water, takeaway food and beverages, and even fresh produce. The plastics are entering the human food chain through numerous pathways, such as ingestion, as shown by the fish studies, but also, surprisingly, through food processing and packaging. For example, fresh food can be plastic-free when it's picked or caught, but contain plastics by the time it's been handled, packaged, and made its way to consumers. Things like machinery, cutting boards, and plastic wrapping can all deposit micro and nanoplastics onto food. Another important pathway for these contaminants to enter our agricultural system is through biosolids sourced from wastewater treatment. Biosolids are a rich fertilizer for agricultural land, but they can also contain plastic particles from many different sources, such as the washing of synthetic clothing. And these particles can build up in the soil and change the soil structure over time, which may affect crop production, food security, and ecosystem resilience. Eventually, some get absorbed by the roots of plants, and that's how we end up eating them. A new study has confirmed that a comparison of brains of teens who are gender diverse and those who are not show no difference in brain size or capacity. However, they're also showing there might be some differences in specific brain features. The findings, reported in the Journal of the American Medical Association, looked at 2,165 teenagers in the Netherlands and found no differences in brain volume, but they did find that for young people assigned male at birth, parts of one area of the brain appear to be thicker among youths who reported gender diversity. While more research is needed, the authors say they're not trying to develop diagnostic tests to confirm a person's gender identity or treatments to, in brackets, fix anyone. Instead, they want to learn more about neurobiology and gender diversity in order to move towards destigmatization and improve the quality of life for people with diverse gender identities. Well, people all like to think of themselves as being the pinnacle of evolution. I hate to say it, but the truth is our brains are somewhat dumb. In fact, it's a wonder we can walk across the room without accidentally killing ourselves. And the proof is you suddenly have no idea how far away something is if you simply close one eye. Also, your sense of danger is largely colour-coded, and your very ability to remain upright depends on stuff in your middle ear. So it's not surprising that when presented with stimuli that your brain simply doesn't really understand, it makes stuff up. And unfortunately for the skeptics out there, that means some people immediately jump to the idea of ghosts or the supernatural. In reality, a lot of so-called paranormal phenomena is nothing more than old-fashioned optical illusion. And Tim Mindham from Australian Skeptics says there's some really common ones out there.
There's a study done, okay, and these pictures crop up all the time in sort of paranormal sites, websites, and on TV, etc. And they're pictures of or videos of a paranormal or whatever activity. And what they do prove is that your eyes can be fooled, and as a witness, you're not very good. Which are two things that are sort of big in the law, as every policeman will tell you. You see things which aren't there, and you remember things which never happened. So the observation powers of people are fairly limited, but they will jump to conclusions, which is where optical illusions come from, whether it's seeing a rabbit or an old lady in a silhouette or two faces kissing or a vase or a face
pareidolia?
Pareidolia comes into a lot. That's about faces and things like that and shapes that face in the cloud, man in the moon, all those things. But you can take it further and you see things which you think are true and even logically true, but that aren't what you think, and there's often simple explanations. One is called the Brocken spectre, which is basically if you're standing in a mist, clouds behind you rather than above you, it's behind you, you're in a mist, and the light's coming from in front, and you'll create a shadow in the mist, which looks like an aura around you because the shadow's a bit bigger than your body is. And that can be on the ground, or it can be in the mist, or it can be all sorts of things. And people say, look, it's an aura, it's a spirit around you. No, it's a shadow. But it's a quite natural explanation for it. It's called the Brocken spectre, and that one happens all the time. There's obviously mirages, and mirages are real, and they can be photographed. You think that they can be photographed, there's not a lot of human interaction necessarily in there, but things floating in the sky, and there's talks about ships floating in the sky, cities floating in the sky.
Yeah, but that's all caused by different atmospheric layers, isn't it?
That's right. But people see it and they think it's a paranormal thing, but then there's this very simple explanation of layers of hot and cold air which interact with each other and magnify and move an image, which is somewhere else. That's pretty straightforward. There's gravity hills, there's one near Adelaide, I think, where you can park a car or stop a car on a hill and it will seem to roll uphill.
Yes.
Same with balls and things, and I remember way back when you're going into the old fun fairs and a magic house, etc., and they'd often have a little sort of rolling ball that seems to be rolling uphill.
Yes,
Coney Island, Lunar Park, all those things, yeah. And they were sort of fascinating because basically you were not sure where the horizon was, you were not sure whether you were level or not, and they used to fool you by having something that looked like it was upright but was actually leaning to one side. And that's what these gravity hills you can't necessarily see the horizon, and you think something is level or downhill when it's actually uphill and vice versa. And that's a pretty standard thing. You don't say it happens all the time, but when there is a place where it does happen all the time, it often gets a name. There's a place in Florida called Spook Hill, which is blamed on the ghost of an alligator, Florida, but it's actually just one of these things where you can't quite see the horizon, so you can't compare it to how things, whether they're flat or not, and you just assume because of the slight gradient, you believe it's going downhill when it's actually going uphill or vice versa. And that's the sort of thing that happens all the time. All these things, there's a whole range of these things about hills, and you think the slope's going the wrong way. So that's a fairly common optical illusion, which is easily explained, but looks impressive. And that's, I suppose, the whole definition of an optical illusion. It looks impressive. A dull-looking one is not going to have much of an effect. A good one will stay in your mind and stay in a lot of people's minds when they see it, but it's not necessarily what they think it is. So your ability to reason, your ability to eyewitness, your ability to see what you want to see are all problems that actually exist in law, courts, and in real life.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.